Thank you again. My name is Jiri Kuthan. I'm with Untitled, and I'll be sharing our operational experience with you today. So I will first, just as a reminder again, SIP stands for Session Initiation Protocol. It's the signaling protocol designed by IETF primarily for voice over IP, but with enough generality in mind so that it can be used for other applications too. Some currently deployed candidates are instant messaging and presence. There may be possibly more. Now, I will tell you what experience we have had at the eptal.org site, which is a non-profit public SIP site where people can get SIP accounts and use them. I will share with you which things are known to work today, and I will spend most of my time claiming and identifying things which are proven not to work today. And I will also tell you what dirty practices we use to tackle with all these problems we are still having. Okay, so what we have today is a site where anybody can subscribe, get a SIP account, like at ICQ, Yahoo. You just pick the first name unless it's already gone, and then you can use whichever SIP software you have. Typically, I don't want to promote any specific vendor, but just to give you a picture of what happens today. Typically, people use Windows Messenger because it's free and it has some additional applications like audio, video, instant messaging. And once they have the name, they can use our signaling server to use the application. And that's basically it. It's very, very simple service. Now, in addition to the public services, we have also some additional services for privileged users like myself and anyone else who works with eptal.org. It's termination of calls to PSTN, it's voicemail, which is a very convenient thing. I mean, I like getting my voicemail messages better by email here than calling back to Europe and having a conversation with an IVR. I mean, that's a painless thing, so I really appreciate such services. The good thing is we already have our own SIP server, which is available on the internet. It's issued under the GNU license. People can try it, people can torture it, people can play with it, and it works. And the services are really are being used today. So it's no more freaks and SIP people who use the site. We see people from the whole globe who get accounts, use them actively. As I said, mostly with Windows Messenger, whose release was actually the triggering point for the growth of our community. And pleasantly, many things work today. So the basic voice over IP services do work, and the complementary services like instant messaging, voicemail do so too. These services are already being commercialized. There are many small startups and some middle-sized companies. There is Vanage, Delta 3, Denva, Packet8, and they really do deploy the things and sell them to customers. There are some trial services like FWD, PCH, WordCom, and so on. And we are being continuously reported on users of our service. So we are sure that there are at least tens of sites which are deploying SIP intranet-wide. Now, despite some common beliefs, many other supporting tools work today too. We have accounting, we have billing, numbering plans work very well too. They actually work much better than for PSTN because with URIs we have an infinite addressing scheme. QoS mostly works pleasantly, at least for our user community. Typically users who try to use voice over IP are aware of they need some bandwidth for it. They cannot use just dial-up. Our users are people who have broadband access, and we have done measurements to all the users who were contacting our site, and we were surprised to see there was absolutely no packet loss, and there was a round-trip time delay of mostly up to 150 milliseconds and almost ever below 200 milliseconds, and that's pretty pleasant for voice over IP users, and you have to realize that they are all in all parts of globe, so it's fairly good in my opinion. Other good news is SIP interoperability is well established today. I'm not claiming that, please don't understand it as if I told every SIP product you see would work. That would be far away from the truth. But if you go shopping and you know which SIP products you have to be looking at, there are already, the good news is there are already established products which have gotten it right, which will work with other products, and interoperation is simply good enough. But you need to know there is two other implementations which are not perfect. I admit that. Fortunately, we are able to interoperate with other technologies too. There is already established market on devices which allow interoperation to PSTN. We have gateways to other instant messaging products and protocols like Jabber. There are commercial products for facing the H323 networks. So that's all quite nice state of the industry. I was not actually hoping to see it so soon, but there are still some nightmares. The biggest one is definitely NATs. That's the most frequently asked question we get on our helpline every day. I'm behind a NAT, in case the user knows that. Please help me out. The other thing which makes me still quite worried is reliability. And I today use voice over IP. I use my cell phone. I try to avoid PSTN. Well, reliability of voice over IP is the reason why I still have a PSTN phone in my corner room. I simply do not want to depend on voice over IP yet, and I will give you some numbers on that. Scalability is yet another concern. I think that devices are not too bad today when dealing with scalability issues. We have done solid work on that, and we can deal with pretty heavy load. What is much worse is scalability of administrators indeed. I mean, if you deploy too many boxes, or if your routing, application-level routing policy becomes too complex, things will become very difficult to manage, and then you will not suffer from lack of CPU cycles or memory, but you will suffer from lack of administrators, and that's a very dramatic issue, which is expensive too. So that's my primary three technical concerns: NATs, reliability, and administrator scalability, manageability. There are some other non-technical concerns today too, and devices are still very expensive. That is indeed the second most frequently asked questions. Thank you for your recommendation. I like the phone with the huge display you suggested me, but do you have someone with some phone which is less than $500? And there are some future issues too. We try to deal with them in technical terms, but these are not easy ones. Imagine that voice over IP takes off heavily, and say at 2 a.m., telemarketers from here, from US and from Asia will call me at 2 a.m. back to Europe and ask me if I was interested in a Chinese forklift. Other thing was denial of service attacks, and this is also a very hard issue to deal with. I mean, it takes a lot of performance, it takes a lot of design considerations. You need to make your infrastructure as stateless as you can. You need to have a reasonable authentication policy. We are working on it. It's still pending concerns. Okay, so let me give some more details on the three biggest troublemakers. NATs. They are very widely used, as we have learned. We don't know how big the problem is. It's very big. There are estimations about millions of users behind NATs. It's very hard to measure. Nobody knows how big the problem is. It's definitely big enough. The problem is that SIP is a very dynamic, SIP applications are very dynamic, and to accommodate their demand for dynamics, they advertise IP addresses, port numbers, and payload, and that is what makes things break. Once the payload gets over NATs, the addresses are no longer valid, and signaling can never complete successfully. So there is, today we have a lot of patchworks and workarounds how to deal with them. And I would love to see some straightforward solution. Of course, that would be IPv6. We could junk the NATs and we would be absolutely happy. Unfortunately, that's not going to happen in the very near future. So I'm just skipping this option in the rest of my talk. So we are left with some methods or with some hacks how to deal with NATs and SIP. And sadly, none of them is perfect. All of them require some additional support either in end devices or in NATs. And none of them is without some deficiencies. Mostly, each of them is better or worse than the other one in certain scenarios, but you can hardly find one which will make all scenarios happy. And you know, scenarios are very different. It depends whether you own the NATs, whether they are owned by provider. It depends whether they have some capabilities and so on. So I'll give you just a quick catalog overview of methods we have seen so far to deal with NATs. It's not exhaustive. There are some more of them. Application layer gateways. It's like the PICs, which was referred in the previous talk. There is geek's choice. I wouldn't believe that, but really people do that in a quite large scale. They configure their NATs to get the port translations right, and so do they configure their phones. There is UPnP, which means that phones are able to detect NATs and control them to get the applications right. There is something which is called STAN, which is a sort of detection protocol which allows you to learn how your application looks outside behind the NAT and use whatever it learned in its signaling. And there is something called relay, which replaces the SIP peer-to-peer communication with a pair of client-server communications, which are easier to get over NATs. All of these are hacks. I mean, I admit that. It's horrible, horrible hacks with many shortcomings, each of them. Now, it looks like we are not able to live with some of them now. I just made a short comparison of what all of the methods take and give. It's very hard to tell today if there is any winner. Relay has very hard scalability issues. Manual configuration is not practicable in a larger scale. So maybe we are left with ALGs, STAN, and UPnP. STAN has the great advantage that it works even if you do not own the NATs, which might be useful in some scenarios. Deploy NATs. GPRS networks are, I think, thought to be NATed by 90%. So we are still here waiting for vendor support. All of these methods take support either in end devices or in NATs or in both. Okay, so that's my biggest concern, and as I told, there are other ones too. Reliability is the next one. I will skip all the cases what can make things go wrong. There are many of them, and as a matter of fact, we need to be able to deal with any failures, whatever is the reason for them. And we are still having a fair gap from the 5 nines reliability of PSTN. I believe, and people here in the room may correct me, that current reliability end-to-end, which is a common value on the internet, is like 99.5. That's the values I have seen at NetMetrics, at an NRIC report. It's being reported in a voice over IP related study by Wenyu Yang and Henning Schulz-Rune. So we need to be able to deal with the lack of reliability. And I mean, redundancy is not extremely difficult to implement. It takes two things. It takes replication of data you have, like current user's location, and it takes the ability to force clients to use the backup infrastructure. Well, the first part is easy, and I know how to do that. What makes me, however, there is a very practical problem with the other part, which is making clients use the backup infrastructure. What is that? Well, as I said, it's very practical. Most current phones are broken, and they are not able to use the mechanism defined in SIP standard, which is DNS SRV. What happens is the phones boot up, learn IP address of their server, and live with it until you turn them off and turn them on again. So that makes actual things very difficult. We have no easy ways to make clients use a backup infrastructure if the primary one is not available. We have been playing with many dirty workarounds like IP address takeover, DNS updates. None of them is perfect. We started looking at rerouting Anycast, but these are still ways which we need to understand better. Okay, the third problem I have today is manageability. I mean, just dealing with the bulk load is easy. There are many reasons for bulk load today. It's new applications, it is broken and misconfigured clients, and we have observed such situations every day on our side. I mean, you just take a misconfigured client, and the load from that client increases by a factor of 120. And on the public internet with many users, things escalate very rapidly. So we need to be able to deal with quite fair load, not just because of applications and the size of user population, but primarily to deal with some failures and broken implementations and other unexpected situations. Now, the good news is that we have been working on it quite hard, and we achieved very nice numbers, like thousands of calls per second of transactional throughput, which gives you fairly good capacity to deal with such abnormal situations. It still is troublesome if someone tries to kill your server by high load at any price. If you encounter a malicious attacker, we measured that a malicious attacker is able to exhaust memory in terms of hundreds of megabytes of RAM in tens of seconds, and that's one thing we are still looking at. That's a real threat. Okay, but in the normal or even less normal situations, we are able to deal with that. What is more difficult to deal with is the application layer routing. I mean, most people here are familiar with IP layer routing, but SIP actually gives you the routing ability at the application layer, and it has some great uses too. Primarily, it's very good for service composition. You're able to glue many different components, implementing different parts of services together, so you can bind your voicemail system to your IP phones. You can glue your PSTN gateway in the picture. You can use applications like weather notification and so on. And that's all doable. SIP is actually very good in that. But the challenge is the ability to glue all the pieces together to create a very reasonable routing policy for that. That's one issue. The other issue is how to deal with situations when you screwed up the routing policy, how to detect the error and how to repair it quickly. So these are two things which are actually, from our experience, essential to deployment of some larger SIP networks with distributed components in it. I'm just gonna skip a set of reasons why your routing policy may be complex. There are many reasons. Differentiation between anonymous and authenticated users, differentiation between calls to PSTN and to IP phones and so on. There are many reasons, and even definitely more than I'm aware of. You just need to be able to deal with the messages. You need to be able to deal with pretty complex routing decisions at the application layer. So that's doable today. We developed a routing language which is able to set the conditions, make your application layer routing decisions based on them, and so on and so forth, and it works. I will not, if you're interested in details, let's take it just offline out of lack of time. The good message is works. I have actually seen it recently in products of two vendors. So it's been recognized that you need these things for operation, and it's making its way into commercial products today too. The maybe harder part of it, as of today, is getting things right when they don't work. Why is it so hard? Well, because the application layer routing may result in a pretty complex path any request takes. It may go through many proxy servers. A proxy server, after it doesn't succeed in a next downstream hop, it may try somewhere else. And what you see here in the bottom of the picture is a real maze over which the request moves. And you have very hard time to learn what's going wrong when a server decides this request is not acceptable to me. I will deny it. And this has been unfortunately for some reason ignored in the IETF. And I think actually that answer to this problem is absolutely simple. I'm wondering why it hasn't been acknowledged until now, maybe because there is too many vendors in the IETF and too few people who really run the things. But the idea is that we simply mirror the incoming request, which resulted in a failure with any negative replies we send out, and that gives the ability to all elements in the SIP path to look at what was the reason for the error. And we already use it in our side, but the challenge is now to move the industry and vendors ahead and make them put this feature in every device. I'll try to allocate some cycles for that, of course. Okay, so I'm in the end. Let me recap once more the things I have seen as important. So the good news is the basic service package is up and running. It works. One needs to be, however, very cautious about things like performance, not just in order to be able to deal with large population size, but in order to be able to deal with abnormal situations, and also to save you running too many boxes, which is a huge administration overhead. Denial of service attacks is still a pending challenge. So the other lesson we have learned in our deployment is that having a routing flexibility is very essential to getting all the components play together. And even more challenging is the ability to troubleshoot the distributed network. And this is still one of the places where vendors are where phone vendors are a little bit overdue. There is too little troubleshooting support. As I told before, there is too little failover support. I'm only aware today of one phone from one vendor which is able to get DNS failover correctly right. And the other thing which makes me perhaps worried most is support for NAT. Again, a lot of things can be achieved directly in the phones, and if there are vendors here in the room, I'm very sincerely encouraging them to think of these issues. If you have any more questions, grab me now. I have posted here some more information resources. Email me, look at our website. You can even try with our services or with our server. It's all on the web. Thank you.